So our new unit is on functions. So right now what we're going to talk about is relations and functions and how they work together. And a relation is any set of ordered pairs, right? That they relate to each other. And they can be shown in the form of where's my a table. You guys have seen a table where you've got like X, Y, something like that would be considered a table. Mapping, which we'll talk about later, or we can map one to the other. Um, the way you guys are most commonly seeing it is in terms of a graph, right? When we have ordered pairs, right? An XY pair, the most common way you see that displayed is in a graph or in an equation. In a relation, the set of X values, those are our inputs, are called the domain, right? Anything that X can be is your domain. There's some crazy stuff going on inside my room right now. They're like creating some kind of a wind vortex. The set of all the Y values of the outputs would be called the range. So when they're talking about domain and range, it's really just your X and your Y. What are you putting in? That's your domain. What you get back out is your range, right? And it's not just that one, it's all of the potential things that you can put in, like that you can make X, and all the potential things that you can get out afterwards, your Y. Um, a relation with distinct points is called discrete. Coming right up to my door. And a relation with connected lines or curves, which is how you're used to seeing them. Like discrete is if you just see like a point on a graph. Those would be a discrete relation if you just got all your points. If they're connected and they have like a smooth line or a curve, those are called continuous. Is that super important right now? No, but it's there, so we might as well know. Continuous. When we're talking about functions, which we'll be talking about a lot for the next several weeks, a function is a relationship in which each element of the domain, right, all of our X values are paired with just one element of the range. What that means is whatever I put in for X can only give me one Y value, right? It can't have multiple Y values. Um, so, in terms of a function, if I had like a set of points, like 0, 1, negative 5, 2, 6, negative 2, negative 5, 7. If I looked at this to know if a set of points was a function, all I have to do is look at the X values. If none of the X values repeat, like here we have 0, negative 5, 6. Sorry, I put in negative 5 again. I was only supposed to put in 5. 5. If none of my X values repeat, then I have a function. It's a legitimate function. If the X values do repeat and they don't have the same Y value, not a function. So if I looked at the set of, say, negative 7, 2, 6, 1, 6, 2, negative 3, 9. If I looked at this set, I would not have a function because I have in here I have two separate x values, right? I have two of the same x values. I have a 6 here and I have a 6 here, but they do not have the same y value. And what a function says is when I put in x, a value for x, so in this case 6, I should only get one y back out, right? So I couldn't have a 6, 1 and a 6, 2. Because what these points say is if I put in 6 for x, I'm going to get 1 back out, or I'm going to get 2 back out. And that doesn't work with a function. You can only have one solution. Another thing that we can do to find out if something is a function is we can do what we call a vertical line test when we graph it. So if I had, say, something graphed, an equation graphed on a line, the vertical line test says that if I drop a vertical line anywhere into the graph of this equation right here, this is our, we'll call it f of x, right? If I drop a line vertically, it can only cross the graph of that equation in one spot. So if I dropped a vertical line here, it'll only cross in one spot. If I dropped a vertical line there, it would only cross in one spot. So a graph of a function would look something like this, right? A graph of not a function, it has all sorts of things it could look like, but say I have a circle. I know that's a really bad circle. I'm aware. But you guys kind of get the idea. You can imagine it as a circle. If I were to drop a vertical line into the graph of this equation, it's going to cross in two spots. So it's not a function. So these are ways we could tell the difference between just a regular equation or relation and a function. Does that make some sense? I have made a video where a dude's head explodes talking about introductions to functions. I don't know if you guys can handle that though. It's a lot. Like a dude's head blows up. So in this first bit, and this is what your homework's going to look like, so pay particular attention. We're just going to decide what is the domain, what is the range, and is it a function? All right. So if I look at something like this right here, and I want to know what the domain is, well, the domain is just all of the x values. So -1, 0, 4, and 6 make up our domain, right? Our x values make up our domain. Our range is just our y values. So that would be the set of -9, -5, 3, and -2. So we've got our domain and we've got our range. Is it a function? Well, we want to know if it's a function. We're just going to look at our x's. None of our x values repeat, so we could say, yes, this is a function. If we look over here, we've got a domain of, well, we've got -3, we've got 5, we've got 8. But notice that we have 5s repeating. So we can say that it's not going to be a function because I've got a 5 that goes to 2 and I've got a 5 that goes to -6. Our range is going to be all of our y values. 2, 4, -6, 0. Should I write them in order? Yeah. But that would have required some forethought on my part. This is a table, but it means the same thing, right? These are just coordinate points written in a table form. This is 7, -8 is my point, right? So if I want to write the domain of this function, it's just all of our x values, 7, 2, 0, -4. I'm going to do it in order this time, -4, 0, 2, 7. And then the range is going to be my set of y values. So I'm going to go -8, -1. 3, 3. Now, let me make that more legible. Do I write both 3s? I really don't need to. 1, 3 would be sufficient to write for my set. Is it a function? Well, if we look at this, none of our x values repeat. We have repeating y values, but that is okay. We can have y values that repeat. But if it's a function, the only thing we can't have is x values that repeat. But none of these repeat. So yes, we have a function. So not terribly difficult. So if we looked at number 4, we could go, okay, well, our domain is 10, 15, 18, 24, right? Our, right, x makes up our domain. Y makes up our range. Look, it's already pointing at the R. Is it a function? Heck yeah, it is. Why is it a function? None of our x's repeat. Follow? Another way they could be represented is in a mapping. So here, all I'd have to do is go, okay, my domain is whatever is an x. So I'd have -4, -2, 5. My relations would be everything that's in y. So 0, 3, 7, 9. Is it a function? Do my x values repeat? No? Then yes, it's a function. Here we've got some craziness, right? But I know that all of these numbers make up my domain, and all of these numbers make up my range. And as long as none of these point to 2 different numbers, we do have a function. And we notice that 2 only goes to 7, 8 only goes to 0, 13 only goes to -4, 17 only goes to 7. So yes, we have a function. Is everyone kind of getting this? Like, give me a thumbs up or something if you guys are. Saw like 2 thumbs. Everyone else probably fell asleep. If I have a graph and I need to determine a function, I look at my x values, right? This is -3, this is 0, this is 2. If I'm looking at these points, right, it's kind of easy. I can go, okay, well, all my points, what's this, -2, this is 4. And I'm going to look at where my points all lie, right? So my domain would be -3, 0, 2, and 4. My range would be all of the possible y's. So we've got 1, 2, 3. This one's 4, 1, -1, -2, 3, 4, -5. So I can look at what all of my y's are where there's points, and I could go -5, -2, -1. Nothing on that point. 1 and 4. So all of my potential points, right? Is it a function though? The way I could tell on a graph is if I have any point going through the same x value, can't be a function. Because this says that when x is -3, I can have 2 different y values. I can have y equals 1 or I can have y equals -2. So no, not a function. This one, though, passes our vertical line test, right? I could drop a line through it anywhere. So we could say that, yes, is a function. If we're looking in terms of our domain, This goes this way forever and this way forever, right? So our domain can be all x's. So negative infinity all the way to infinity. And our range is the same, right? It can go up forever, it can go down forever. So again, we've got negative infinity to positive infinity. Now, this we can look at and say right away, not a function. I could drop a vertical line there. It's going to cross at more than one point, right? So we know that's not a function. My domain, though, starts at 1, 2, 3, 4, 5. I can't have anything less than x is equal to 5, right? So we could say our domain is x is greater than or equal to 5. Our range, however, goes forever up to infinity and forever down to infinity. So our range would still be negative infinity to positive infinity. Is number 10 a function? Thumbs up, everyone, if you think it's a function. Y'all need to participate a little bit. I got one participant in that thumbs up. Is it a function? Thumbs up or type yes or no into the chat box. Question 10. Anybody else? If I drop a vertical line down through this, we're going to cross at more than one spot. So my no's have it, right? It is not a function. If we're looking at our domain, our x values run from here to here, right? So from -2, I should put this in a parentheses, all the way to +5. That would be our domain, right? Everything from -2, I should have it in brackets because it can actually be -2 and it can be +5. Our range, same thing, goes from -2 up to 1, 2, 3, 4, right? It goes up from -2 up to +4. Also, we get brackets. Why brackets? Because it can equal -2 and it can equal 5. But no, it is not a function. Our other method that we're looking at is with equations and whether or not they can be functions. A lot of times you have to just kind of look at something like that. First of all, I have minus x squared plus 3. There's a couple things I know about that. If you don't know what the graph of this looks like, use a graphing calculator online, plug in the equation, right? But I know anything with an x squared has a parabola graph, right? In this case, it's a negative x squared. So if I graphed it, it would look something like this, right? It would be a u forever and ever. And so I could tell by the vertical line test that that's a function, right? There's certain things that I know, though. Like one is that my domain, I can put in anything I want for x. How do I know that? Because my arrows go forever in this direction and forever in this direction. But y is going to start at 3, right? Well, it's going to end at 3, I should say. It can go, notice it's all pointing down, so it's starting at negative infinity in both directions, and it can go to 3, but it can't go anywhere else. And is it a function? Yeah, if we dropped a vertical line in that, it would only cross. Wherever I put that line, it would only cross in one place. And so you're going to kind of want to go through problems like this and see y equals -7, right? It's just a line like this at -7. So my x values, I can have any x value, but my y value, the only y value I have is going to be -7. No matter what I put in for x from -infinity all the way to infinity, my y value can only be -7. Where if I look at this one where I've got x is -1, it's a terrible graph, right? That is a line, oops, can pretend that's a straight line, right, at -1. So no matter what I have, my domain is only -1, but my y value can be anything from -infinity to infinity. This, no function. This, yes, function, right? Because I can't drop a vertical line into a vertical line, right? For number 14, but for number 13, it's just a line that goes all the way across, right? I could drop a line anywhere into it, a vertical line into it anywhere, and I'm only going to cross it at one point. So, what time does this class get out? Let's make sure I have time for this. Oh, I do. The next thing we're talking about is function notation. All that means is how we write functions. And you guys have seen it before. When we're talking about function notation, if I have an equation like y equals x, 2x plus 7, and I want to write it in function notation, I would write it as f of x equals 2x plus 7. And all that means is that x is the input and y is the output, or f of x is the output, right? F of x is essentially y. But what f of x really means is the name of the function is f and our input value is x. That means if I put anything into it, it's going to go into the x value. So if I have f of 3, that means anywhere there's an x, I'm going to put in a 3. So here it says if f of x equals 2x plus 7, find f of -3. Well, f of -3 would be 2 times -3, because that's where my x is, plus 7. And we would go 2 times -3 is -6, plus 7 equals 1. So we could say that f of -3 equals 1. And your assignment is going to work just like these problems right here. You're going to be given two equations. Here I have f of x equals -5x minus 14, and I have g of x equals -x squared plus 9x minus 1. And so if it says f of -9, we're going to use the f equation. If it's g of something, we're going to use the g equation. So if I have f of -9, I'm going to use minus 5 times -9 minus 14. So I'm using this equation when it says f of something. And then we're just going to do the math. That's 45 minus 14, which is 31, right? So not so bad. You guys know how to plug numbers in. This one right here says g of -7. So I'm going to use the g equation, which is going to be minus x squared. Well, for that x, I'm going to put in -7 squared plus 9 times negative 7 minus 1, right? I'm using the G equation that's up here. Negative 7 squared is 49, but I have a minus on the outside, so it's minus 49 plus 9 times negative 7 is going to be, what is 9 times 7? Negative 63 minus 1. That's minus 50. That's going to be negative 113. So do you kind of get it as far as those plugging numbers in goes? What if I have something? I'm not going to go into all of the problems, but I just want you to see, like, this one's got 2 f values. It says f of 1 minus f of 4. I would write that as minus 5x. Well, I'm going to take the f of x problem first, and I'm going to go minus 5 times 1 minus 14 minus, and I'm going to do the same thing in a quantity, so I make sure to minus the whole thing, minus 5 times negative 4 minus 14. And I'm going to solve it out like that, right? We're still plugging in the same thing. This becomes minus 5 minus 14. This is plus 20. But when 20 minus 14 is 20 minus 14 is 6, right? So this is minus 6 now. And then I have minus 5 minus 14. That's minus 19 minus 6 equals minus 25. So think about what you're doing with this. A problem like this one right here, where I'm plugging in the G, I've got 2 times G of 12. So we got to go to this G equation. We've got minus x squared. Well, that's minus 12 squared plus 9 times 12 minus 1. We're going to put that in brackets, and at the end, whatever we get, we got to multiply the whole thing times this 2 on the outside. So 12 squared is 144, so I've got 2 times negative 144. 9 times 12. What is 9 times 12? Is that 108? I think it's 108. Plus 108 minus 1. And once we figure out what this mess is in here, I can multiply the whole thing times 2. This whole thing, I think, equals negative 37. And so I would have now 2 times negative 37, which is negative 74. So will it get confusing? A little bit. You're going to have stuff with fractions in it? Heck yeah. But all of your problems are going to be just plugging in the numbers. So you're going to have stuff where you have to find the domain and range like we were doing up here. And then you're going to have stuff like this where we're just plugging things into the equations. But you'll have them both on the same worksheet. I'm having to do all the problems because I'm mean. I'm an awful person. Make sure you show your work. If you'll notice inside it says show your work where you can. Really, right here on the function stuff, not much work to show, right? You just write down what the domain and range are. You don't really have any work to show. But on the problems where you're plugging in numbers, you do have work to show. Make sure you show it. Don't just give me answers. But that is all I have for you, although I do feel like it's a lot.